Okay, let's continue chapter 3. Okay, chapter 3.3-2. Okay, today I think we need to learn about the HOG and HON. System should be able to, once you have a difference equation, we should be able to find the HOG and HON. And then after that, we need to, solve the difference equation. So once you solve the difference equation, the output is total response. Total response consists of zero input response. Zero input response, input is zero, okay? And because of initial condition, we have some input, that zero input response. Without initial condition, the zero input response must be zero, okay? So that total response, same with zero state response. Zero state response is total response in the case of the initial condition equals zero. Okay, so zero state is initial condition equals zero. Okay, so that we have learned from now how you find the HOG and also HON and find the zero input response and zero state response and total response. So that's the rest of the chapter, okay? Okay, so for example, suppose let's go to the slideshow. Okay, suppose just like electric circuit, but this is the digital circuit. We have this circuit given, and then last time we found the difference equation. So output feedback to here and one delay and multiply by A and addition and input plus this one and that's Y of n, something like that. So this is for one delay, the first of the system. So once we have a difference equation, okay, then suppose in the case of A equals 0.8, for example, then Y sub n and this one to the output side, that is a plus is 0.8 or minus 0.8, Y of n minus 1 and X of n. So once you have the difference equation, this one, then we must, we can apply the G transform. Okay, G transform. Okay, each term. So this is Y of n. It's all Y of G. Okay, and then this is minus 0.8. One delay is G to the minus 1 and Y of G and equal X of G. Okay, so Y of G is a common term, then this is 1 minus 0.8 G to the minus 1. So now output over input. So output over input that we define as a transfer function H of G. So this is 1, right side is 1. This is the other side is top, bottom denominator part. So we have 1 over this guy. Okay, so one delay. So we multiply by each term, G. So G and G minus 0.8. So we have here. So in this case, it's H of G. Transfer function is G over G minus 0.8. Okay, so in here we found the 0 is G equal 0 origin, and pole is G equal 0.8, and region of convergence is the exterior of from the largest, the largest pole. Okay, so magnitude of largest pole, so 0.8. Okay, so this is H of G. Okay, so in the G domain is the real part of G, x-axis, imaginary part of G, y-axis. Then the 0 mark as a circle, a pole mark X, and region of convergence is the exterior of the case. In these cases, we assume that this is right side sequence, okay? Right side sequence, okay. Okay, so the second order system. Suppose we have a digital circuit like this, then definitely from here last time we found this difference equation. So once we have a difference equation, then each term we apply the G transform. So y of g plus 1 over 4 g to the minus 1 delay y of g, and plus y 1 over 16 2 delay g to the minus 2 y of g, and equal x of g. So we can do like that. Common term is y of g, and here we can take this is x over here and this guy is here. Then y of g over x of g, which is defined as a transfer function, and this is one of that guy. So this is second order system. So if you have a partition, okay, so factor, then this guy is a factor like this guy, okay? So you can use a C factor or C solve, whatever you can use it, so you can find that guy. So this case is, we have two zeros, 2 poles. Okay, so 2 poles, 2 0 and 2 poles. So 0 is g equals 0, and same point, g equals 0. We have a 2 0 and 2 pole is this is conjugate, and then magnitude of this guy is 1 over 4. Okay, this one magnitude. So the region of convergence is exterior of the circle of the 1 over 4. Okay, so this is look like the one. It's this is one of this is the 1 over minus 1 over 8 and plus j square root of 2 over 8 or something like that again. Right? And this is if you polar form is a magnitude is 1 over 4, and then angle is 2 pi over 3 radian per second. Okay, so we can do this guy. So that's x of g. Okay, is okay so far. Once we have a difference equation, you should be able to find h of g, right? Any question? This is very straightforward. Okay. All right, let's take an example, another example. So this, we assume that the right side sequence, okay. So this is, apply the G transform, y of g. This is g to the minus 1, y of g. 0.16 g to the minus 2, y of g. This is 1 delay, so g to the minus 1, x of g. 0.32, 2 delay, g to the minus 2, x of g. Okay, so like this one, okay? So take a ratio, okay, ratio y of g and x of g, so which is h of g. So this is numerator part is, this one here, and denomination part is this go to here, okay? So this is this is second order system. So each term multiplied by g squared. So this is c squared is a g, and this g times g squared is for 0.32, and the g squared plus g, okay, the g and plus 0.16, this one here. Okay, and then we can factor. Okay, we can factor. So this is after we factor, we can find the 0 is a g equal minus 0.32, and pole is minus 0.2 and minus 0.8. So region of convergence is the largest one, magnitude of largest one, so 0.8. Okay, exterior of large. Okay. So far it's okay. Anybody has a question? So far it's okay, right? I think because we have a background of a continuous time cases for the Laplace transform, H of S, and very similar with this. Okay. Now, why don't you do that, guy? I'm going to do only a few of them. Okay, so which one do you want? Among this one, which one do you want? Okay, let's do the first one, A. Okay. Okay, can you see my writing in the red pencil?
Yes.
Okay. Okay, so the first one is just y of z. Okay. So there is one delay. So one delay is, this is, okay. This is a g to the minus 1. Okay. G to the minus 1 and x of g. Okay. And 10 times. Okay, so that is 1 over g minus 1. Okay, so you can do. So this is y over z over x over z, which is h of z. Okay, so that one is g to the minus 1, g minus 1. So multiply g. So this is 1 over g and g minus 1. Okay, which one do you want? Other thing, just one more. Anybody?
Can we do E?
E. Okay, E. Okay, E. So we're gonna do one by one, and so this is y of g, y of g, y of g. Okay, so now I will do that. Y of g. This is a common term. First one is just 2 minus. Second one is 3 and 1 delay. Third one is just 2 delay. Okay, and then x of g, so this is x of g. Okay, and then first one is just 4 minus 3, 1 delay. Okay, so this is y of z. Okay, over x of g. Okay, so which is, we said that this is h of g. Okay, and equal 4 minus 3g squared and 2 minus 3g to the minus 1 plus g to the minus 2 equal. Okay, so that this is a causal form, make a non-causal form because this is second order. You know, each term multiplied by g squared. So this is 4g squared minus 3g. Okay, this one, first one is 2g squared minus 3g plus 1. Okay, so you can find the factor here. So, you know, this is important, okay? So let's do the using calculator. I click it, right? One more. Go slow. Oh, come here. Come on. Oh, we have two of them. we have two of them. Okay, so let's do the, okay, let's perturb this guy, okay? So I don't know, this is 1/3, 2, 2, 3, 2, 1. I don't know whether we can try the, solve. So current to solve. Come on. Uh-oh. It doesn't work. So. I don't know, my calculator it doesn't work at all. My calculator has a problem. Big problem. I don't know that. Solve. Okay, so 2g squared plus minus 3g plus 1 equal 0, comma, j. Okay, if, oh yeah, this is not complex value. So, so 1 and 1/2. Okay, so this is, ooh. Okay. Okay, so this is 4g, okay, and g minus 3/4. Can you see my writing, right? So that is g minus 1, g minus 1/2. Okay. Is that correct? Is that correct? Yeah. So g equal 1, g equal 1/2. Okay. So this is correct. Okay. So that 0 is we have a g equal 0. Another 0 is a g equal 3/4. And pole, we have two pole, g equal 1, and then g equal 1/2. And the reasonable convergence is, the reasonable convergence is g magnitude is greater than 1. Biggest one. It's okay? So far it's okay, right? So everyone understand, right? Then let's go to the next slide. Okay, so unit impulse response. Unit impulse response, once you have, h of z, then, impulse response, inverse G transform is h of n. Very simple. Okay, so, h of g, then, take a inverse G transform. So that's a h of n. So for example, this guy, we are in the case of a equals 0.8. So first order system, we found h of z is g over g minus 1. So very simple, okay? H of n is inverse G transform is 0.8 to the n use of n. So, we using previous, okay? I'm going to provide the table, so this is very easy. Okay, so that's h of n, all right? So h of n is look like that one. Okay, second order system is the same thing. So this case is h of g, we found the previous example. So this one here, then we can make a factor here. Now, we're going to partial fraction expansion. Okay, so in the case of partial fraction expansion, don't apply directly partial expansion of this guy. You need to apply the partial expansion for the divide by g. So one of g is h of g over g, okay? So you need to apply the partial fraction expansion, h of g over g. And then after that, and multiply g again. So we have a g and g. Okay. So that case is a equal, okay, a equal easily. So this is from here is 1 over g is eliminated, so g, okay, and then g plus 1a plus j square root 3 over a, and g equal, okay, g equal minus 1 over a. Okay, so this is plus j square root 3 over a. Okay. Okay, so far it's okay. So you can using calculator. Okay, so let's do the calculator. Okay, let's do. Okay, so using calculator. So we're gonna type as it is. Type as it is just g over parentheses g plus 1 over a. Okay, plus I and square root 3. Okay, square root 3 and over a. Okay, and parentheses. And then now bar and g equal minus 1 over a. Okay, plus j. Okay, square root 3 over a. Okay, so if you enter there, then this is, we can find that this one is, oh, I forget it. I forget it. Okay, so this is allowed, I write down here. So this is 1/2 plus j square root 3 over 6. Okay, so that, okay, so this one is equal 1/2 plus j square root 3 over 6. I think you can do, change it to polar form. So, okay, so using the polar form, then, easily you can do, change it to polar form, catalog, so polar. Okay, I don't know, it work directly or not. Oh yeah, it work directly or not. So this is 3 over, square root 3 over 3, and angle is 30 degrees. Okay, so this one, okay, this is a square root 3 over 3, and E3, J3, okay. So 30 degrees is, I think, a pi over 4, right? Pi over 6, pi over 6. Who is I don't know who is it, whose name is here. iPhone, who is iPhone? I don't know about this guy. Okay. So that, we can find that guy, okay? So you can see using table. So using table here. So I think last time I recommend the, instead of this one here, so multiply by 2, that's a better way. this is just a, some constant. This is a gamma, okay. So gamma, in the case of gamma, is this is gamma here, a gamma. So that is a polar form. We need to find the polar form, okay. So in this case is, we don't have to do like this. This is a square root of 3, okay, square root of 3. So, you can use this table as it is, so like this, it's fine, either way, okay? So we can find this guy, and then we can apply the, partial, the inverse G transform.
What would beta be?
Okay. So this is 20, table 20. I'm going to provide the table. Okay, so this is R equal, in this case is R equal 2 over square root of 3. So we're going to plug in here 2 over square root of 3, and then magnitude is 1/4, 1/4 to the n, and cosine, this is beta, okay, so 2 pi over 3. So 2 pi over 3 to n, and plus, and then 30 degree is pi over 6, and use okay. Okay. It's okay, right?
How did you get 2 pi over 3 for
2 pi
beta?
over 3 is this one here. This one. Okay. So
Pick up the phone.
oh, I'm sorry.
Abby, pick up the phone.
How'd you calculate beta there to 2
Oh,
pi?
beta is gamma is a gamma first one. It's a gamma is this one. Okay, this one. So this is gamma is this one. Then G equal root is G equal 1 minus 1 over 8 plus J square root of 3 over 2. So this one here. Okay, and then this is you need to change it to polar form. Okay. So you can you know that how you change the polar form, right?
Yeah. Okay.
iPhone, flatbread, okay. But I don't know about the other iPhone. Okay. All right. So that I think you can use the calculator very easily. So you can find that. All right. So that, for example, polar form is, my case is, instead of by hand, I use normally, or, minus, 1 over 8, okay, and then plus, and then, J square root to 3 over 8, and then you can use catalog, and then I use a polar, and then I type like this. So this is the magnitude is 1/4, the angle equal 120 degrees. So the reason is I set up as a mode to the degree. So if I set up as a radian, for example, okay. So for example, then I think you can get the magnitude 1/4 and e to the j 2 pi over 3.
Okay. Cool. Thank you.
Yeah. All right. So, but instead of by hand, I strongly recommend to use a calculator. You calculator, no error, and then more fast, more accurate. Okay. All right. So you can using, this is for you, because we know this case, we know already about the h of g. For this h of g. Okay. So for example, E, in the case of E, I think one of the example of the h of g, this is when we did, a long time ago, long time ago. Unit step function. Okay, so let's write down. Okay, let's have an E over here. Okay, so E of g is I'll write down here. So h of g was 4g, g over 3 over 4, and then g minus 1, and g minus 1 over 2. Okay, so we're going to go back here, and then okay, so we're going to go back here. And so in the case of the E, okay, as an example, we found the H of Z was 4G, G, and G minus 3 over 4, and G minus 1, and G minus 1 over 2. Okay, so we're gonna apply the partial fraction expansion, okay? So partial fraction expansion, okay, let's using calculator. This case is a real number, so we using very easily we can do. So, so partial fraction expansion, this is just expanded. So, F2, okay, and expanded, and then two people. Why you take? So why did he always go out? I don't know. Okay, so expand it, and then you need to eliminate the G, okay, because H of G over G, okay. So instead of 4G, so I'm gonna do 4 parentheses, okay, 4 parentheses, and then G minus 3 over 4, okay, and then divide by, and parentheses, G minus 1, parentheses, and multiply. You need to do a multiply, otherwise you have error. So G, okay, minus 1 over 2, okay. So this is parentheses, and parentheses is the denomination part, and then it's another parenthesis for the expanded. So you can using, okay, so this guy here. So this is, 4 or 4, the 4 over 2. 4 over 2 is a 2, okay, right? 2 over G minus 1 half, and plus 2 over 2G minus 1. And then multiply by G again. So because we did G again. So this one is, so 2G and G minus 1 half, and plus 2G and G minus 1. Okay, so yeah, inverse response, the inverse G transform. Inverse G transform is, H of N is, let's do the first one, this guy. So this is 2 use of N, okay, plus this is 2, this is also 2. 2 and 1 half to the N, and all of use of N. Okay. So far it's okay? It's okay, right?
Yeah, so you
follow
just
me,
did
right?
expand of the H of Z and you got that? Because I got
Right.
I got that, but I also got +4.
Yeah,
So
I got +4 too.
I wasn't sure if I did that wrong.
Okay, which one? So did you do eliminate the Z, this one?
Did I eliminate that Z?
Okay, so
No, is that what you asked? Did I eliminate the Z?
okay, so did you do the like this? Okay, expand. Okay, I thought.
No, I did not do
4.
it that way. I didn't eliminate the Z. That's why.
You did not.
I did not. So that's why.
Oh, you should one.
Okay, yeah. So that's what I got. I
yeah.
thought we'd already eliminated the Z, so that's why I didn't do it.
Yeah, otherwise you don't have any, this G. You don't have a disease, then you have a problem. Okay?
Okay.
Okay, so this is right, okay? All right, I'm glad, everybody. All right, so another one is a stability test. Stability test is a two-way. One is, using H of Z. So pole is located inside of unicircle.
Do you think there's any way you could go back just that last slide? I didn't get the solution wrote down. If
Okay,
you don't
go
mind,
ahead.
just 1 second. Yeah.
Okay.
I just want to make sure I got it.
Okay.
I appreciate it.
Hey, no problem.
All right. I got it. Thank you.
Okay. Okay. All right. So that stability test is, just like same in the continuous time cases in the S domain. G domain is a pole must be located inside of a unicircle. Last time the continuous time case, the pole must be located left hand side from J omega axis. But in this case, in a distal case, pole must be located inside of a unicircle. Okay, so unicircle is as the frequency response, and then the another stability, BIBO stability is magnitude X of n is must be summable. Okay, so first one is it's starting from BIBO stability. We know already about it. So this one is all pole, H of G, all pole of H of G must be located inside of unicircle, Okay, so if anyone is outside unicircle, then it's unstable. Is that clear? Is that clear, right? Okay, and then BIBO stability is, conclusion is, the magnitude of H of n must be summable. We usually say that the system is stable if and only if the H of n, unit impulse response, must be absolutely summable. So converge, H of n magnitude.
So if any poles are greater than 1.
Greater than outside the unicircle, okay? Outside the unicircle, then is unstable. So pole must be, for the stable system, the pole must be located inside of unicircle. Is that clear? So inside this unicircle. So unicircle is from origin, the magnitude is 1. Okay. So inside of unicircle. And BIBO stability is, impulse response must be absolutely summable. So take absolute, and then approach it to not infinity. That is going to be BIBO stability. Just like that one. Okay. And another one is a pole located on the unicircle like this one. Then we say that the marginally stable. However, we have a pole located in unicircle, but it's a multiple repeated root. Repeated two root on the unicircle. Then this is unstable. Okay, that's it. Very simple.
Is marginally stable like how it was before, where it won't be BIBO, it'll be BIBO unstable?
BO is unstable. Yeah, it's normally unstable.
Okay.
BIBO unstable. Okay. So, and then, exactly same thing. So only different is in distal cases, this unicircle is frequency response, and S domain is J omega axis. That's a frequency domain. So only different is compare with the J omega axis. In distal cases, unicircle. Okay. So that's a very simple. Okay, for example, in these cases, suppose pole is in real axis and then inside of unicircle, then decaying like that. And if in this case minus up and down, -1, -1, so this is anyway is a converged, so it's stable. Okay. In the case of the complex value inside of unicircle, then oscillatory, but it's a converged. Okay. But in the case of outside in real number, then this is +1 is increase it, negative outside of unicircle in real axis, then it's going to be up and down and diverge anyway. But in the case of the complex value outside of unicircle, that is oscillatory, but the diverge. Okay, suppose we have a two root on the unicircle. Okay, unicircle, this is unicircle, only one of the unicircle is steady. So this case is BIBO unstable. However, that is a marginally stable like this. Okay. So there's a two pole. Two pole is on the 1 or -1. Then it's going to be ramp function. Ramp function is diverged, unstable. BIBO, unstable. This is unstable. This is also unstable. Okay, just like that. Similar with this. So it's on the unicircle. On the unicircle, that case oscillatory or continuous never die. But that's the reason BIBO unstable. However, we say that the marginally stable. Suppose we have a two pole on the unicircle in same point, then this is oscillatory. However, ramp function diverge, so unstable. Okay, so I think that graphically you can see. You analyze the system. So mostly digital system is your program also analyzed like that. Okay. So in the case of first order system, first order system, we know that h of g, and then this h of n is because inside of unicircle, this system is stable, and then also this is because of this stable. Okay. However, h of n is 0.8, and then summation of this guy is 1/1+5. That this is not infinity. There's a BIBO stable. Okay, just like you can test it. Second order system is the same thing. So that second order system of this guy here, then we can find the pole and zero. So all pole and zero is inside of a unicircle, so that this is stable. And also h of n is here. This h of n is minus 0.2 to the n. This is 0.8 to the n. And then, summation of this guy is less than converge. So that's a BIBO stable. Okay, so just like you can test it. So as an example, for example, okay, let's say, find the given system is stable and unstable, marginally stable, h of n. So first of all, stable or marginally stable, as you know that h of g. Okay, once h of g, what's a g transform unit step function? So that's a g over g minus 1. Okay, so in this case is this is zero is located in the origin, and then pole is located in here. So this is on the unicircle. That this is marginally stable. Okay. However, okay. All right. So marginally stable. So I need to erase it. This guy. Okay. Okay. So this is marginally stable, and also we can using the summation of this guy here. Summation. This is the use of n is 1. One, starting from 0 to infinity. So 1 to the end. So 1 plus 1 plus 1 plus 1 plus to the infinity, that's infinity. So this is BIBO unstable. It's a never die. That is, not converged. So this is BIBO unstable. However, because the pole is located on the unicircle only one, not repeating root, without repeating root. So this is marginally stable. Is it okay, right? Everybody understand, right? Okay, yeah. So what about this? Okay, go ahead. Okay, let's do this guy. So n times use of n. N times use of n, if you take a G transform, then G transform was, we know that G transform was G over, okay, so G minus 1 to the square, right? So we have this one here. So we have a two pole on the same point. So these are repeating root. So that's unstable. Okay. Is that clear, right? Everybody follow? It's okay? So far? So far, so good?
Yeah.
Okay, so let's take only one here. Anybody? Select it.
Let's do C.
C. You always choose a very difficult one.
You always give difficult ones on the
Good
quizzes and
call. Good
exams.
call.
I don't know whether difficult one. But okay, C. Okay, so first of all, h of g. Okay, f of g is this is the input side. Just this one is g to the minus 2. Output side is 1 plus 2 g to the minus 1 plus 3 over 2 g to the minus 2. Okay, so this is everybody g squared, so this is 1 g squared plus 2g plus 3 over 2. Okay, so it depends. Depends on this guy, okay? Is it real or
What happened to
real?
the 1/2 y n minus 3?
What happened? Oh, I forget that. Okay, thank you very much. Please.
No problem.
Okay, 1 over 2. I didn't. Okay, so like that. All right, so this one is that's a very good calculation. Okay, right? That means that at least even though I cannot see you, so that means that okay. So this is totally wrong. You don't sleep it, right? Okay, so this is G. Okay, each term multiple by G cube, okay? So G cube and G square and G and plus 1/2. All right. Okay. So I don't know. This is depend on that guy. So let's do the factor of that guy. So let's do using factor, okay? Okay, we're gonna continue next time because time is over, okay? So we keep this in mind, okay? Please. And then we're gonna test it, this guy, okay? So we start
All right, thank you.
Wednesday, all right? Wednesday, see you Wednesday. Thank you very much.
See ya.
Okay, thanks.
Mm.